Okay, thank you, Alexander. So as Paul already said, so airtightness is becoming more and more an important issue, in particular in the context of this energy performance of building directive recast. And that's also the, let's say, the topic of the first presentation. So building and ductwork airtightness in the context of the EPBD recast. This presentation will be given by Rémi Carrié, who is working as senior consultant for INIVE. Rémi, the floor is yours.
Thank you, Peter. Yes, my name is Rémi Carrié, and I work as a consultant for INIVE, which stands for International Network for Information on Ventilation and Energy Performance. INIVE is a grouping with several members in France, in Spain, Germany, Belgium, Norway, Greece, Netherlands, Italy. And well, there are a number of projects which are important to INIVE, and three of which are really important to this webinar. The first one is the IDC, tight band, and there's of course built up. The IDC is the International Energy Agency Information Center on Energy Efficient Ventilation and Energy Efficient Ventilation. There's a growing number of countries in the IDC. We now count 17 member countries, and well, I think it's a good sign of the interest of the scientific community on ventilation and infiltration issues. And I would like to encourage you to have a look at the IDC newsletters if you want to have more information about what is going on within the IDC. Another project is tight band, which has been initiated by INIVE with several sponsors, and it aims to disseminate information and raise awareness on building and ductwork airtightness, keeping in mind, of course, the need for appropriate ventilation. Again, I would like to encourage you to have a look at the tight band newsletter if you want to have more information on tight band activities. And there is, of course, build-up mentioned previously by Garcia and Peter Wouters. And in fact, my presentation and the one that Valérie Leprince will give in a few minutes are closely linked to the overview article, which you can see on the screen now, and which you can download from the build-up website. So my presentation will be divided in a few sections. So the first chapter will be about increasing pressure on building and ductwork airtightness with the EPBD recast. Then we'll talk about the requirements in EU countries, and about the incentives through calculation procedures and subsidies. And then we'll try to draw some conclusions and perspectives. So with regard to the pressure on building and ductwork airtightness with the EPBD recast, well, there are several sources that report an energy impact on the order of 10 kilowatt-hour per meter square per year or floor area for the heating needs in a moderately cold climate. That's for the envelope leakage, and about 0 to 5 kilowatt-hours per meter square per year for the ducts, plus the additional fan energy use. Well, this has been reported in the past, and you can find some information about that in the ADP reports, which have been funded by the Intelligent Energy Europe program. But there's also some more recent work on these aspects, and I would like to focus on 3 studies which are more recent, which I thought were interesting to mention during this webinar. The first one is a study that was conducted in the UK, a study where they looked at 2 similar dwellings in 2 phases. In the first phase, the 2 dwellings had about the same leakage at tightness, And in the second phase, the airtightness of the second house has been improved significantly, as you can see here. And they have measured also the heat loss coefficient in the two phases, and they showed that with the decrease of the air permeability, they also saw a significant decrease of the heat loss coefficient. So I thought that was very interesting because this is based on experiments. Most of the time we have results on the impact of the air permeability based on simulations. In this case, it's based on experiments, and I thought that was quite interesting to mention that. They conclude based on that that 15% energy savings are achievable in the UK building stock. Second interesting study, I think, was a study that was conducted in Spain on office buildings in Madrid. And I thought that was interesting to mention because we very often mention envelope and ductwork airtightness for cold climates or for mild climates, but it's also a concern for hot and mild climates. And I thought that was interesting also to mention that study, which you can download also from the REBA website. It was a special issue of the REBA journal in January 2013. Finally, there's a study that was conducted in France that showed a good convergence between indoor air quality and good envelope air tightness, provided, of course, that you have an appropriate ventilation system. You can find some information about that in the IBC newsletter. There was an article recently, I think it was in the second issue of the IBC newsletter, where they have shown that improving building air tightness was actually converging with better indoor air quality in the test cases they have looked at. So all of this shows that it's actually relevant to put pressure on building and ductwork air tightness in the context of the EPBD because, well, obviously it has a big impact on the energy consumption. And, of course, if you want to go to nearly zero energy buildings, you have to pay attention to these aspects. Well, also we see that in this context, requirements evolve. Although there is no explicit requirement for air tightness in the directive, it is not explicitly required in the directive to pay attention to air tightness. But what we see is that, in fact, most regulations include the impact of air tightness. And, in fact, poor air tightness is often penalized in energy regulations in the member states. And even in some countries, there are explicit minimum requirements. So you can find some information about that, again, in the IDAP project reports. But we've also performed a survey more recently, which is still ongoing. But with this, we have more recent information about how the requirements evolve. So, well, here's a table with the various countries we've looked at. So I'm not going to go through all the details of the regulations. Of course, it would take too much time. But on the other hand, I think it's interesting to see that the indicator is, I mean, there's a range of indicators, I would say, because you have Q50 in some cases, N50, W50 in some cases, also in Denmark, for instance. You have also the airtightness indicator, which is used at 4 pascals in France. So it's kind of interesting to see that it's there's a wide range of indicators that are used. And also, what is interesting is to see is that there are, in some cases, minimum requirements that are imposed. Well, in many cases, as you can see here, because there's a lot of yes. So basically, what are the lessons learned from this survey? I think the first one is that most countries account for building airtightness in their AP regulation. Second one is that several countries have minimum requirements either for specific programs or for regulations. There are mandatory testing. There is mandatory testing also that applies in several countries. The market share, on the other hand, varies a lot depending on whether it's for a specific program or for the whole regulation. There are also several airtightness indicators that are used, and finally, we've seen also that there's credit for better airtightness, ductwork airtightness in Belgium and also in France. So with regard to mandatory testing, we've seen that it has come gradually into force in several countries. I think it's in the UK, which we see the longest history about that because they started since 2002 having mandatory requirements on testing building airtightness. So it says that subjecting samples of newly built dwellings to pressure test is compulsory. In Portugal, there are also tests which are mandatory for HVAC systems in buildings larger than 1,000 meters square. In Denmark, there's also mandatory testing for no less than 5% of the construction projects. In Ireland, also, with tests that must be carried out in dwellings, but there are something rules that apply. And finally, in France, with now since 2013, airtightness tests that have to be airtightness that has to be justified for all new residential buildings, either with a test or with an approved quality management approach. And there's also ductwork pressurization test, which is mandatory in F-energy buildings. So with regard to now incentives to promote, I would say, better airtightness, there has been also incentives in the calculations and also in subsidies. As we can see, most energy regulation include the impact of building airtightness on the overall energy performance calculation. We've seen that in the ICP report, and this was confirmed more recently with our survey. And most of the time it's done with a default value, where in that case testing is not required. But in that case, of course, in general, you have no attention to airtightness. And, well, in the case you would like to have a better airtightness, which would be relevant because it's cost efficient, then you have a substantial decrease on the foreseen energy use of the building. Well, there's also incentives through calculation procedures, through quality management approaches, in France. In that case, it allows non-systematic testing. So basically what that means is that instead of testing all buildings, for instance, if you're a builder and you build 5,000 houses a year, you can test only 10% maybe of the houses in order to justify that you have taken care of airtightness correctly. So initially it was controversial, of course, because well, some people thought that it was unfair. All buildings had to be tested, but in fact we see that well, it's more or less positive as of today. there's positive feedback, of course, although some improvements are always possible. I like to show this graph where we see on the x-axis the air permeability at 4 pascals, and on the y-axis the cumulative frequency. Here it's on the red, with the red curve, is without quality management approach, and you can see that well, the median value is about 0.5, I would say, and with the quality management approach, this is the green light here, you can see that the median value is smaller, it's about 0.4. And also what is interesting to see is that the spread between the biggest and the smallest air tightness values is smaller in the case of quality management approach. In other words, it's easier to predict the result, and you have more confidence that you will have an airtight building in the end. Also, I should say that it has been an essential element to allow a minimum airtightness requirement in the new regulation in France. So there's also good, the fact that good airtightness is sometimes used as a precondition for specific programs, and this is, of course, a big incentive for practitioners. So, for instance, if you apply for programs that are based on passive house or min-AJP standards, then you have to do an airtightness test, and you have to justify that you have good airtightness of your building. And also what we've mentioned in the IACI project report, also regarding Norway with the governmental house bank that gives economic incentives if you have good airtightness, and also in France with the BBC energy label since 2007, which is endorsed by the French government to claim for subsidies. So now, of course, there are some questions that are raised. We see that the requirements evolve, but does the market react positively to these changes? Does it change? Does it improve the quality of buildings in practice? And also, how do we set up effective control frameworks to avoid wrong declarations? I would say intentionally or not in the EP calculations. Of course, I mean, having a mandatory test is something interesting, but if this test, if there's no control on this test, I would say it's not necessarily a good thing, because if you have wrong declarations, then you don't have a guarantee that the building will actually meet the required performance. So as a summary now, let's say that we've seen that recent studies and developments confirm the relevance of improving building and ductwork airtightness in the EPBD recast context. We've seen that through experiments that show that the energy consumption can be significantly reduced with better airtightness, with simulations also, and we've seen also convergence between better indoor air quality and better airtightness, so that goes in the same direction. We've seen also that airtightness requirements evolve significantly in the member states. We've seen that more and more countries require explicitly airtightness testing for specific programs or for a wide range of buildings. So we've seen that with mandatory testing that was imposed in France, in the UK, in Denmark, at least for some part of the building stock. And finally, we've seen that these changes raise a number of questions, including how to efficiently control the compliance with regard to airtightness. And actually, the presentation of Valérie Leprince will give some more information about this last aspect. In other words, how do you make sure that when you check the compliance of a building with regard to airtightness, well, you have good confidence that the result is going to be actually reliable. So with this, I would like to thank you for your attention and thank also our sponsors and the IBC for being able to conduct this work with entitlement in the IBC. Thank you.